In this series of videos, we're using the openFrameworks C++ Creator Coding Toolkit, an XBox Kinect sensor, and we're going to build ourselves a 3D photo booth. Welcome back. In this video, we're going to continue looking at the XBox Kinect 3D sensor. We're going to turn our point clouds into properly meshed triangulated 3D models and build ourselves a photo booth. In previous videos, we've been working with XBox Kinect sensor, and what we're going through applies to the Kinect 1, Kinect 2, and pretty much any other depth camera that you might want to work with. Previous videos, we've looked at using the OFX Kinect add-on for openFrameworks. We've added a GUI in. We've set the camera up. We update it. We worked out how to take information from the camera and draw a point cloud, or to draw out the RGB and the depth images. We added a simple GUI that we could control our thresholding, and we put in some key controls so that we can draw a point cloud, draw our GUI, toggle full screen, and we also added the ability to save our point cloud out as a PLY file that we can take into other 3D modeling or rendering software on Mac, Windows, or Linux. We wrote a simple function that loops through X and Y coordinates of all of the points that the Kinect sensor is detecting, and we push them into an OF mesh object called point cloud, adding vertices at every point. And that allowed us to debug, run full screen, and also build a point cloud that we can set clipping on, so I can clip out the back wall of my studio or clip me out. But this time, what we're going to do is we're going to take our point cloud of dots that you can see and triangulate each of the dots to make surfaces so that we can actually render the surface of our objects with the colors that we're getting from the RGB camera. And we do this by taking this grid of dots and triangulating between a dot, the dot next to it, and the dot below that, and then back up to make a triangle out of 3 points, which is one side of a triangle, a left-hand side, and to make the right-hand side, we go from the dot down, across, and back up. So we make 2 triangles that interlock with each other to make a surface. So the first thing that I'm going to do to make this much simpler is I'm actually going to take out our test that we put into the draw point cloud, where we're saying if the point we're looking at is closer than this or further away than this, exclude it. Just for simplicity's sake, I'm going to comment that test out. And if I run that up again, you'll see we're now going to sample all the points that we get back from our Kinect sensor and build them into a point cloud by adding the vertices into our mesh. I run that full screen, and you can see, if I line this up, it's pretty much sort of rectangular. And we're going to sample every single point that's appearing in our point cloud. Now the challenge is that some of this data, as you can see, there are holes in the mesh. Some of the data is coming back from the sensor null. Even when I have my hand, you can see there are points of it from reflectivity, my ring, and so on, and bits of shadows, where there's no data coming back from the sensor, especially where part of me is shadowing, for instance, the back wall of the studio over here, behind my arm, and so on. It's in the shadow of the infrared emitter, so there's no data. And the challenge is that when we try and, if I stop that, come down to this routine that I've made to triangulate my points and uncomment it, what we're doing is we're saying get the width and the height of the Kinect sensor, which gives us our grid to go through. And then exactly as before when we made the mesh, we're going to step through every point in the Y and every point in the X direction. And then we're going to make 2 triangles. Here's the routine to make one. And we use this add index command. Just up above you can see we're adding a vertex. It's a point with an XYZ coordinate into the point cloud mesh, one after another in rows. Here we're telling it which index to connect, which vertex to connect with an index. So we're making triangles. So we need 3 points in the triangle. We'll make 3 like this, and then 3 corresponding kind of like that, and it makes effectively a square out of 4 dots. And what we do is we start at point 0, move across to point 1, and then move down to point 1, 0 to make one triangle. And then we'll do the opposite, which is start at point 1, go down to point 11 and across to point 1, 0 to make the other triangle. So we'll make 2 triangles that sit together to make a square to start meshing our surface. So we're going to do this now with 2 loops to make one triangle and another triangle. And there's a problem. And I'm going to show you what the problem is. But before we do that, we're going to change up here our point cloud not to be of primitive points. We're just going to leave it as standard, so it'll mesh and show us our indices. And down here, instead of saying point cloud draw vertices, just the dots, we're going to say point cloud draw wireframe. So it'll draw our wireframe between our dots. So I'm going to set this to compile now, and this should grab our Kinect data, give us a debug, and set this full screen. My point cloud now is being triangulated, but it's doing something quite weird. And if I zoom in a little bit, you can see that it is actually generating triangles running away there, looking very pretty on the screen. Parts of my ear, parts of my face. I can see the back wall of the studio, the roof of the studio. But if I zoom out, I can see that something's not quite right. And what's happening, if you can see that on the screen, is where there are holes in the image, where there's null data, I'm triangulating with these enormous triangles from valid data, such as on the back wall, my hand, my face, and so on, with all of this null data. So I'm making bogus triangles in places that I want to get rid of. I only want valid data to be triangulated. So I need a way to go through and say, is this point in my mesh valid for me to make a triangle out of or not? There's a couple of different ways to do this, and we're going to do a brute force rough version. But what I want to do is, as I'm going through my first run, adding vertices into my mesh, pulling the data from the Kinect sensor, adding a vertex into the mesh, I want to say, is this a valid point or not, and record that. So in my header file, I'm going to make a vector of integers. I'm going to call it point index, and I'm just going to say yes or no, all of the points that we run through. It's a valid point, it's not a valid point. And then when I make my triangles, I'm going to check against this to say, can I make a triangle out of these 3 points? So I'm going to uncomment this little routine that I've written here. I'm saying when we pull point data from the Kinect sensor using getWorld coordinate, we make a vec3 point, so it's got XYZ data. If that's valid data, that's fine. So I'm going to say if point Z, implicitly it's true, I'm going to push at the end of my vector, my index vector that's saying yes or no, good data, bad data, good data, bad data. I'm going to push a 1 to say yes, this is good data, we can make a triangle out of this point. But if it's not, I'm going to push a 0 into this list. So I have just a list of ones and zeros, good data, bad data. When I try and triangulate, if all three of the indices I've made are good data, they all are ones, I can make a triangle. If any of them are not, it means I'm going to get these funky, weird triangles, so don't try and triangulate it. So coming down to the routine to triangulate my mesh, here's where I add the three indices to make each triangle, and I'm going to just add in this if statement. It's a little bit long, but I'm saying if in my vector, my point index vector of ones and zeros, this point, the x plus y times the width, so I'm counting down one line after another, is true, and the next point and the next point, i.e. if this point and this point and this point have got not null data, they've got good data in, make a triangle. And the same here. I'm saying if this point and this point and this point have got good data in, then make a triangle. So if I compile this now, this should crop out all of the null data from the triangulation routine and give us a good mesh and triangulation. Press F for full screen, press P for point cloud, and this is looking very promising. And if I zoom in, you can see I'm getting kind of good triangles and they're working. Now, at the top of my hand, you can see we're getting this sort of tearing in some places, but it's making sense. It's not data that's running from my hand or from the side of my head or from other points off to a 0 point. It's actually where there's a piece of valid data and right next to it, but a long way away, there's some other valid data. So we're not discerning how far away the points are. We could add an extra routine to say, actually, if the z distance between 2 points is too big, let's treat them as separate objects and not triangulate them. But for now, this is good enough, and we could go and tidy all of this up, and there are routines to do infilling to guess where there are little microscopic holes in the mesh and so on, and tidy all of that stuff up. But we can look at that another time. But right now, we've got pretty reasonable looking triangulated data. And there's one more thing that I'm going to do. I'm going to quit. I'm going to come to where I'm drawing my wireframe and actually say instead point cloud draw. So now this will draw the point cloud mesh, including the indices to triangulate, and make filled surfaces. I get my debugs, hide my GUI, run this full screen, and there is my triangulated and surfaced mesh. And as I move around, you can see the back wall of my studio and the various different things that are in here. If I move the sensor around, you can see there are other desks on the other side of the studio, and graphics cutters and plotters and all kinds of different things. And if I bring this back down and we look in, the last bit is the routine that we've got when I hit the S key that will take this whole mesh and save it out as a PLY file, including the index data and the triangulation data and the color data that we're putting into the mesh now. So if I look heroic and hit the S key, that should have saved out the whole 3D data as a 3D model that we can then open up in MeshLab as we did last time. So let's go and have a look. Here is my cloud PLY file, and if I say open with Mesh Lab, there is our triangulated 3D model. I just tell this not to be shaded, and there we go. That's actually a surfaced 3D model, and if I tell Mesh Lab to display it in different ways, I can see the wireframe information, tell this to be shaded. So there I've just got my wireframe. If I want, I can see just my point cloud data, which we saw previously, or I can ask Mesh Lab to draw me surfaced model. And now I could clean this up in Mesh Lab, or I could take it into Blender, take it into Unity, take it somewhere else, and do things with it. So we've built ourselves a 3D photo booth. If you like the video, please do keep watching for more that are coming up. Hit the subscribe button so you know when I put more tutorials up. If you like it, please hit the like button and leave me comments in the comments section below. Ask me questions. I'm very happy to help out, and if you've got suggestions or improvements, please do let me know as well. On the screen you should be able to see the link for the GitHub repo with the source code in, and you can catch me on Twitter and on Facebook, and I look forward to seeing you on, you can find me on Twitter, you can't find me on Facebook, you can find me on YouTube here, and God, this is a mess, and I look forward to seeing you next time. Hit the subscribe button.